Okay, so this is part 2 of our DME 1115 Introduction to ICTs and Computers. So basically, what is a motherboard? So a motherboard basically is defined to be a circuit board, okay, as indicated there. So a motherboard, in other terms, is can be referred to as the main printed circuit board. So we are talking about the PCB, printed circuit board. Okay, so we know what a circuit is, right? So the circuit that is printed on a board, this is what you're seeing there. When you open your systems unit, what you're seeing there is what we call the motherboard, where all the things are attached. That's what we're calling the motherboard. Okay, so the motherboard contains the processor, the memory, connectors, expansion slots. So what is a processor? What comes to your mind when you think of a processor? So a processor basically is the one that performs the basic functions. Okay, so processor is one that is now, as the name entails, processing input to output, trying to convert our data into information. All that is done by our processor. Okay, now memory. What do we think about memory? Of course, we are thinking of memory to be storage, right? So memory has got something to do with storing of information. Okay, so just a proper definition of a processor. We can define a processor to be the logic circuitry that responds to and processes the basic instructions that basically gets to drive a computer. Okay, so these processors can be found in computers. What is personal computers? Maybe smartphones, tablets, and also other kinds of computers have what we're calling the processor. So whenever we're talking about the processor, think of a CPU in short. Whenever we're talking about a processor, think of a CPU to make more sense. So we know a CPU is made up of what we call the arithmetic logic unit and also what we call the control unit. Okay, now what are connectors? What comes to your mind when we say connectors? So basically, when we are talking about a connector, we are trying to think of ways and means that we can use to connect to a computer. So think of a port that is available there. So that is due to the connectors that are available. So for example, is the SATA connector, there is the ID connector, 24 pin ATX power connector. So all those are connectors. They allow for different functions. So as you can see, the ATX power connector there. So what we're trying to say is a connector can be used for power supply. It can be used as a mic input. It may be connected to a speaker or headphones output. It may be USB. It may be for internet. It may be a VGA cable, for example, projector. It may be other things. Yeah. So all in all, think of connectors as ways and means as we get to connect to the systems unit or to the motherboard via a port. Okay, and then expansion slots. When you're talking about an expansion slot, basically an expansion slot is a connection or a port inside the computer on the motherboard. So it basically provides an installation point of for a hardware expansion card to be connected. So they are what we call expansion cards. So as the name entails, expansion slot. So what basically do we get to use expansion slot for? So expansion slot may be used to put cards that are, cards like for video, maybe for sound, for advanced graphics, for internet or for memory. For example, RAM, we can put a RAM on an expansion slot to just increase the memory of our computer. So expansion slots, as the name entails, it allows us to expand the capabilities of our computer by either improving video, sound, graphics, internet, and memory, among the other functions. Okay, so in summary, that is basically what is the motherboard. Okay, so here is our CPU and main memory. So what is the function of the CPU? So basically, when you're talking about the CPU, I said think of a CPU to be the processor. So a processor is basically the CPU. Okay. So alternatively, we can call our CPU to be the processor. Okay. We can call it the central processor or just microprocessor. So we're referring to one thing there. So the CPU is basically the central processing unit. The letter stands for central processing unit as indicated. And then a computer's CPU handles all the instruction it receives from hardware and software running on the computer. So we know that hardware basically gets to perform according to the instructions received from the software. Now it is the duty of a CPU to handle the instructions that it gets to receive. So we can give an example. The CPU processes the instructions for you to access a web browser on your computer. Okay, so it's a duty of a CPU. So the CPU is often referred to as the brain of a computer because many believe it thinks like a human brain. So basically, think of a CPU to be like a brain of a computer because it's kind of thinks, but it doesn't think, but we can think of it in that way. However, it is more appropriate to refer to software as the brain and the CPU as an efficient calculator. A CPU is a little good with numbers, but without software, it can't do anything. It can't think. Okay. So a chip part executes program commands. So this is an example of a processor that we can have. Usually in most of the computers we have Intel running there, and of course there are other things. There are other processors that also gets to run. I'm sure people are exposed to computers are able to tell that we do have other processors on our computers. So it's what we call AMD. It's another kind of a processor that we have, and among others. You can find out more. I believe it's beyond our scope in the study. And then we also have what we call a main memory. So a main memory is the primary storage area for programs and data that are in active use. So as I'm using the laptop now to make this video, every information that is here is basically temporarily stored in the main memory. So the main memory is also referred to as the RAM. So everything that is in active use, when you're playing a game, it is basically you are using the RAM of the main memory. So it is the primary storage area for programs and data that are in active use. And the main memory stores information. It doesn't require you to save. Even without saving, just know that that's where the information is. Okay. So that's what main memory is. And of course, one thing that I would want you to know about the main memory is that it is based on the semiconductor integrated circuits. Of course, beyond our scope, we can categorize RAM to be there's static RAM and also dynamic RAM. But for now, just know that RAM is the primary storage area for programs and data that are in active use. So when a computer turns on, everything that you are doing on a computer is stored in the main memory of the RAM. Okay, so as we get to proceed, we'll find out that we also have what we call secondary storage. Okay, so secondary memory provides long-term storage. So as you think of RAM can lose data. So that's why we're calling semiconductor memory. So it gets to lose data when the CPU loses its power or the computer goes off. The information that was stored in the main memory gets lost. Now there's also what we are calling now the secondary memory, which provides long-term storage. Even after going off, they still retain the information. So information is moved between the main memory and the secondary memory as needed. Hard disks, floppy disks, these writable CDs, tapes are examples of secondary memory devices. So these ones are able to store information for a long period of time. So the information can be moved from the main memory to the secondary memory devices if the information is required to be stored for a long period of time. For example, when you're typing a document without saving, it is stored in the main memory. If you get to save, it's going to be stored in the secondary memory. Of course, nowadays computers are made in such a way to say even without you saving, there's a bit of an allowance to retrieve the information I believe there is some storage in the secondary memory. Okay, so input output devices, where we talked about this. So IO refers to input output. So input, we're trying to give instructions or data to a computer. Output, ways and means where a computer gets to communicate to us. So when you immediately press a letter V on your keyboard, it's going to appear on the monitor. So that is already an output. So that's why we're looking at this. Keyboard is inputting, the monitor is outputting. What is doing that? That is all being identified by the CPU. So the CPU is identifying whatever is going on. Okay, so these are examples of the input devices, I believe. Or it's a combination of both input and output. So a monitor is an output, a keyboard is input, a mouse is input, a barcode scanner is an input device, light pen is an input, touchscreen is both input and output. Okay. So analog versus digital. So there are two basic ways to store and manage data, analog and digital. So basically, to make things easy for you is think of an analog clock where you have numbers indicated 12, 6, and then you have 9, you have 3, and then think of a notch that is like showing, okay, let's say it's 0, 3, 0, 3. Yeah, so this is digital, one is analog. So that will help you think fast and just get to summarize this. So analog is continuous and is in direct proportion to the data presented. Music or a record album, all these examples of analog data representation. So when you look at when you're editing a video, for example, you'll be able to see to say, or when you're recording sound recording on recent smartphones, they show things like this. So that is an example of representation of what we're calling continuous. Okay, so what is analog data presentation? Continuous. And then when you look at digital, the information is broken down into pieces and each piece is represented separately. So music on a compact disc, the disc stores numbers representing specific voltage levels sampled at various points. So this time around, all our storage is based digitally. So digital is broken into pieces and usually exact. It's non-continuous as compared to analog. Okay. So examples of digital information. So numbers, texts, graphics, images, audio, video, program. Computers nowadays store the information digitally. In some way, all information is digitized, broken down into pieces and presented as numbers in a computer nowadays. So we are trying to show how the representation is done in the computers now. So every character is stored as a number, including spaces and digits. Punctuations are also given numbers in a computer. So of course, as we will see later, computers use what we call binaries, zeros and ones, to represent everything that we have. So corresponding upper and lowercase letters are separate characters. So as we can see, do we have what we have? Try to compare. So when you compare small letter h, it is 116, and then you look at the other one is 72. So small letters and uppercase letters are separated, are represented using separate characters. So that may be a question that may come under multiple choice, so take note of that. Now, those numbers you were seeing previously there, they were not represented as they are. So all those numbers, all these numbers you're seeing here, would have to be represented now in binary, because that's what a computer basically gets to understand. So binary means 0 and 1, only two numbers involved. So once information is digitized, it is represented and stored in memory using the binary number system. A single binary digit is either a 0 or a 1, and that is called as a bit. Devices that store and move information are cheaper and more reliable if they only have to represent two states. So a single bit can represent two possible states. It may be a light that is either on, represented by a 1, or off, represented by 0. So combinations of bits are used to store values. Okay, so all in all, in summary, what we're getting here is binary involves zeros and ones, and a bit can either be a 1 or a 0, where 1 is on and there 0 is representing off. So zeros and ones allow us to represent two different states, for example, on or off. Okay, so bit combinations. So 0 1, 0 0. So when you are talking about a bit, we are talking of a 0 and a 1. So when you say a bit, it's either you have a 0 or a 1. When you say two bits, you have two numbers. So it's either you have two same states or different. Or this. So you have either two zeros or two ones, or, and of course, depending on what comes first, you can have different combinations. So as you're saying, 3 bits, when you have 4 bits. So one thing that we can observe here is, for 1 bit, possible combinations are 2. For 2 bits, we have 4 combinations, we have 8, and then I believe we have 16 combinations. So what would you say there? Are you able to observe a certain trend that is kind of happening? So if you say the first one is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So do you believe it is the number of possible combinations are dependent on the number of bits, where n is the number of bits? Okay, so bit combinations basically can be summarized with a formula that we've derived to the power n combinations of any bits. We've seen that already. Okay, so a computer specification. So we call this, usually some of you have already dealt with computers, we call this, what are the specs? Yeah, so specs stand for specifications of a computer. So some of the specs that you may see are 2.4 gigahertz, which is the speed of the processor, and then RAM, that is the main memory, 1 terabyte hard disk, so that is secondary memory that allows long-term storage, where you keep videos, where your images are kept, that is hard disk. So 24x speed CD-ROM drive, the size of a monitor, 1 GB modem. So what does all this mean? Let's try to understand what all this means or represents. Okay, so basically memory is divided into memory locations or cells. Each memory has a numeric address which uniquely identifies it. So that is very, very important for us to understand. Each time the CPU is allocating instructions to memory, it uses the addresses, or what we're calling the memory locations of the cells. Okay, so all these are represented using numeric addresses, using numbers. Okay, so this becomes more in detail for people who may be doing architecture, who's doing other courses like computer science. But for you, I think that is enough, and it is beyond our scope to go that far and understand how we have the registers and whatnot, the counters, what basically happens in the accumulator, what changes when instructions are received and whatnot. Okay, so let's try to move on. So storing information. So each memory cell stores a set of number of bits, usually 8 bits or a byte. Large values are stored in consecutive memory locations. Okay, so we've been told that. So large values are stored in consecutive memory locations. So when you have large values, you'll be able to use 2 spaces to just make sure they all get to fit in. So not only are the memory locations represented using numeric values, but even the information stored in there is also stored using numbers. Of course, the information is stored or represented using the binary operations in memory. Okay, so storage capacity. Alright, so every memory device has a storage capacity indicating the number of bytes it can hold. So one thing that we need to be aware of is a byte. 1 byte is makes up 8 bits. Okay, that's also very important. Remember, a bit, we said a bit is either a 0 or a 1. So if you can have 8 numbers, zeros and ones combined together 8, you have 8 bits. That forms a byte. Now a byte can be represented in other forms, as a kilobyte, as a megabyte, gigabyte, terabyte. I'm sure we are very much exposed to these. So for example, when you say my memory card is I'm having a 4 GB memory card, or a flash 4 GB, basically what do you basically get to mean in terms of a byte? So in terms of a byte, what we're thinking of is think of a kilobyte, and then get to think of a megabyte, get to think of a gigabyte. So all you're going to be doing is be moving in terms of tens. So a kilobyte, as we can see, is the power 10, the power 20 is megabyte, gigabyte the power 30, and terabyte the power 40. So that will be easy for you to remember. And of course, when it comes to the conversions that are there, one thing that you basically get to notice is the fact that if you get to compare, for example, a kilobyte, so you find that 1,000 kilobytes will make up a megabyte, 1 megabyte. So 1,000 megabytes will get to make up a gigabyte. Yeah, so and then 1,000 gigabytes will get to make up a terabyte. So that's how easy these things are for you to remember. Main memory is volatile. I mentioned this. So main memory represents the RAM. So stored information is lost if the electric power is removed. That's what it means when for memory to be volatile. The main memory, which is the RAM, random access memory. This is where the data of instructions that are running at a particular time are stored temporarily. Secondary memory devices are non-volatile. This means that they don't lose information when the power is lost on a computer. When you switch off your computer, the secondary memory is non-volatile. It will not lose the stored information. Main memory and disks are direct access devices. Information can be reached directly. The term direct access and random access are often used interchangeably. A magnetic tape is sequential access device. Since its data is arranged in linear order, you must get by intervening data in order to access other information. So to just summarize this for you guys to understand in a bit simpler way, this time around, if you get to connect your USB flash disk to your computer, you are able to use the mouse to click on whatever you want to access randomly or directly. Of course, if you get deep into the computer science, you realize that random and direct basically are different forms. But in this case, we would take them to be one. And then there's also what we call sequential. Sequential, back some time when we used to have those the magnetic tapes, you realize that if you have got 2 movies, for example, on that magnetic tape, you have to access first of all watch the entire first movie. If it means you using fast forward to, but you're supposed to like go through it before you get to go to the other one. That is what we call sequential access. Sequential, you access them in the way they were stored on that media, and then direct, you access them irrespective of the order in which they were stored. So that's what we're trying to talk about under the direct and the sequential access. So the RAM is direct access. So of course, you know what these letters stand for: random access memory, read-only memory for ROM. The terms RAM and main memory are basically interchangeable. So usually we refer to, when we're talking about the main memory, we're referring to RAM. ROM could be a set of memory chips or separate device such as a CD-ROM. Both RAM and ROM are direct access devices. RAM should probably be read-write memory. So the random access memory can be called read-write memory. Okay, so this is where the things are happening when you are trying to perform tasks on a computer in the active use. The CPU, the central processing unit. So the CPU is also known as the processor or the microprocessor. It continues to follow the fetch, code, decode, execute cycle. So these are the three cycles. This is the cycle of a CPU. So there is fetching, there is decoding, and then there is execution. Okay, so if we get to like go deep in the computer science, so fetching is you're trying to get the information. You're trying to get the information from the instruction register. First of all, what you're going to be given is you have the instruction register. You have things like the memory address. So use the memory address to locate the instruction. And then when you locate the instruction, so fetching is locating the instruction, the location of the instruction. And then decoding is now what determining what the instruction is, trying to understand what the instruction is. Okay? Because the funny part is the instruction register stores the next instruction that is coming. So it will be the duty of the CPU now to call the next instruction according to the instruction register. Now when that instruction is called, or we call it brought into memory, we are going to have now decoding, which will now be determining what the instruction is. And then after it is determined, now the instruction will be carried out, which we call execution. So there's fetch, decode, and executing. So those the registers are very much useful in that process, but for now it's not part of our study. The CPU contains the arithmetic logic unit, which performs calculations and decisions making. The control unit basically coordinates the processing steps, and then registers are small storage areas that I was talking about. Of course, we have some of the examples. We have instruction register, memory buffer register. There are a lot of registers. So, but we are not studying that under this. So the speed of the CPU is controlled by the system clock. The system clock basically tells you how fast the CPU is. The system clock generates an electronic pulse at regular intervals. The pulses coordinate the activities of a CPU. The speed is measured in gigahertz. So we saw that on the. So I'm sure we saw that on the specs. It was like 2.4 gigahertz. So that basically tells us how fast our CPU is, and I believe we understand what is means in our physics, so we can connect that. So the other thing that we had saw on the specs was the monitor. So there's the size of a monitor. So this is in inches. Size of the monitor is measured diagonally, so which is like this way. That's how we get to measure the size of the monitor. So it's measured like a television screen. Most monitors these days have multimedia capabilities. They're able to display the text, graphics, video. A monitor has certain maximum resolution, indicating the number of picture elements called pixels that it can display. So I'm sure we know that laptops, computers have got different sizes. So their monitors, there is a maximum resolution that you need to find out. When you're trying to buy, they are what we call specs. So you'll be able to see the size there. High resolution or more pixels produces sharper pictures. So this can come under multiple choice. Take note of it. Whenever the resolution is high or whenever you have more pixels, you can produce sharper pictures, more clear. Data transfer devices allow information to be sent. So we are talking about a modem. So data transfer devices allow information to be sent and received between computers. Main computers include a modem, which allows information to be moved across a telephone line. A data transfer device has a maximum data transfer rate. A modem, for instance, may have data transfer rate of 56,000 bits per second. So many computers come with a modem, which allows information to be moved across a telephone line. So that's basically the use of a modem. And of course, it comes with a data transfer rate, which is measured in bits per second. Of course, when you're talking about a bit, you're talking about a 0 or a 1. So 56,000 bits, or 56 sum of zeros and ones, thousand as transferred per second in most of the cases. Okay, so now in the next video we'll cover the networks, talk about the different kinds of networks that are there, the addresses, how you get to interpret them.